ವೆರಿ ಗುಡ್ ಮಾರ್ನಿಂಗ್. ಲಾಸ್ಟ್ ಕ್ಲಾಸಲ್ಲಿ ಏನಪ್ಪ ಅಂದರೆ ಕೆಮಿಕಲ್ ಇಕ್ವೇಷನ್ಸ್ ಆ್ಯಂಡ್ ರಿಯಾಕ್ಷನ್ಸ್ ಚಾಪ್ಟರ್ಗೆ ಸಂಬಂಧಪಟ್ಟಂತೆ ರಿವಿಷನ್ ಕ್ಲಾಸನ್ನು ನೋಡಿದ್ವಿ. ಈಗ ಆ್ಯಸಿಡ್ ಬೇಸಿಸ್ ಆ್ಯಂಡ್ ಸಾಲ್ಟ್ಸ್ ಈ ಚಾಪ್ಟರ್ಗೆ ಸಂಬಂಧಪಟ್ಟಂತಹ ರಿವಿಷನ್ ಕ್ಲಾಸ್ ಅಂದರೆ ಕ್ವಶನ್ ಆನ್ಸರ್ಸ್ ಟೈಪ್ ನಾವು ಡಿಸ್ಕಸ್ ಮಾಡ್ತಾ ಹೋಗೋಣ. ಹಾಗಾದರೆ ಹೆಚ್ಚು ಟೈಮನ್ನು ವೇಸ್ಟ್ ಮಾಡದೆ ನಾನು ಸ್ಟಾರ್ಟ್ ಮಾಡ್ತಾ ಇದ್ದೀನಿ. Multiple choice questions. First one, if a solution turns lead litmus into blue color, then its pH value is, okay, then its pH value is what? 10. Okay, red litmus paper turns blue. Okay, acids turns blue litmus paper into lead, blue litmus paper into red. Okay, basis turns red litmus paper into blue. We already discussed. That's why what they asked here, if a solution turns a red litmus paper into blue color, then its pH is okay, 0 to below 7 means 6.9 up to 6.9, those are acids. Exact 7, it's a neutral. Then 7 to 14, it's a base. Then if you see here options, first one is acid, second one acid is, third one acid, but fourth one only base. That base makes a what? Red litmus paper into blue. So answer D. Second question, which of the following medicine is used to treat indigestion? ಓಕೆ, ಅಜೀರ್ಣತೆ ಅಂತ ಕರಿತೀವಿ. ಅದನ್ನು ಟ್ರೀಟ್ ಮಾಡಲಿಕ್ಕೆ ಕೆಳಗಿನವುಗಳಲ್ಲಿ ಅದು ಯಾವ್ದು ಯೂಸ್ ಮಾಡ್ತಾರೆ ಅಂತ ಕೇಳಿದ್ದಾರೆ. ಆ್ಯಂಟಿಬಯೋಟಿಕಾ, ಆ್ಯಂಟಾಸಿಡ್ಡಾ, ಆ್ಯಂಟಿಸೆಪ್ಟಿಕಾ, ಎನಾಲ್ಜೆಸಿಕಾ ಅಂತ. ಹಾಗಾದರೆ ಇದಕ್ಕೆ ರೈಟ್ ಆನ್ಸರ್ ಯಾವುದಪ್ಪ ಅಂದರೆ ಆ್ಯಂಟಾಸಿಡ್. ವಿಚ್ ಒನ್? ಆ್ಯಂಟಾಸಿಡ್. ಆಪ್ಷನ್ ಬಿ is the right answer. 1 minute. Option B is the right answer because antacids acts on whatever the acid produced in our stomach. To neutralize those acids, antacids are helpful. That's why indigestion, okay, to treat indigestion we use antacids. Antibiotics are used to kill bacteria. Okay, antibiotics are used to kill bacteria. Then antiseptic, whatever the organism entering our body through cuts and wounds, okay, to kill them we use antiseptic. Analgesics are painkillers. Painkillers. Generally toothpaste pH is 7. Its pH is 7, then it's a neutral. Okay, generally toothpastes are neutral. They are not acidic, they are not basic, they are not amphoteric. Next, the nature of a calcium phosphate into enamel. Okay, our whole body works at a neutral state. That's why maximum, if our body is neutral, it's going normal. But enamel, it's a calcium phosphate, it's a one salt means it is a basic. Basic. An aqueous solution turns a red litmus solution to blue. Excess addition of which of these following solution would reverse the change? See here, if a aqueous solution turns a red litmus into blue means it's a base. Now this property we are going to reverse means blue litmus paper now change into red with the help of which one? Acids. That's why we want to convert this solution, whatever the aqueous solution is there, that aqueous solution turning the red litmus paper into blue. Now we are reversing that process. Excess addition of which of the following? Here they given 4 materials. With the help of which of these we can able to make that solution into acidic? Okay, they asked. That's why baking powder not possible to make that solution acidic. Okay, lime, with the help of lime also it's not possible to make that solution acidic. Ammonium hydroxide is a basic solution. That's why this is also not convert that solution into acidic. But hydrochloric acid is a strong acid that converts that solution into slightly acidic. or what if you add a more aqueous solution, then it makes what more acidic, and then red litmus paper turns into blue. Whatever the aqueous solution's character is there, it's changed. That's why it's answer option D. Which of the following gives a correct increasing order of acidic strength? Okay, acidic strength. See, water, hydrochloric acid, acetic acid, they given. Okay, the pH of water 7. Then acetic acid, the pH of water 7. Then acetic acid, if we take about 5 to 6, 5 to 6. Then hydrochloric acid 1.2 is there. Okay, that's why first one, which one comes? Water after acidic acid, acidic afterwards hydrochloric acid. Then which option? That's a first option, water, acetic acid, hydrochloric. It's a right. It's a right. Okay, this one also wrong, this one also wrong, because increasing order they asked, ascending order they asked. Okay, ascending order, what? First, whatever less pH, whatever the substance has a less pH, less acidic is there, that first comes. Slightly acidic, then comes next. Highly acidic comes last. Highly acidic comes last. One of the constituents of baking powder is a sodium hydrogen carbonate. The other constituent, okay, slightly this question is wrong, I think. Why? Because what they asked, one of the following constituents of antacid. What antacid? What one of the following constituents of antacid is a what? A sodium hydrogen carbonate. Sodium hydrogen carbonate, NaHCO3. The other constituent is a tartaric acid, because mixture of NaHCO3 plus tartaric acid, it's called as a what? Antacid. Okay, we use what? Any what weak acid with a sodium hydrogen carbonate whenever we are preparing a what? Antacids. Next, eighth question. The pH of the gastric juice released during a digestion. The pH of a gastric juice released during a digestion, they asked. Okay, the pH of the gastric juice released during a digestion, it's a more acidic. That's why less than 7. Less than 7. More than 7, it's a basic. Equal to 7, it's a neutral. Okay, equal to 0, it's a highly acidic. Our body can't tolerate that much acidic solutions. That's why less than 7 is suitable for our body. That's why gastric juice contains less than pH less than 7. Next, which of the following used for dilution of dissolution of gold? Okay, it's aquargia. We already studied in our 8th standard syllabus, old syllabus. Aquargia is a mixture of hydrochloric acid and nitric acid in the ratio 3:1. Okay, that we already discussed. That's why what in hydrochloric acid and nitric acid, uh, if they are in both mixture, that solution is called aquargia. In aquargia, gold is dissociated. Gold is dissociated. Next, which one of the following salt does not contain water crystalline? Water crystalline. Okay, if you if we take a blue vitriol, here also water content is there. Sodium carbonate, Na2CO3 into 2H2O, we write. Sometime 10H2O we write decahydrate. That's why it also contains a water. Washing soda, washing soda washing soda, Na2CO3, 10H2O. Baking soda, NaHCO3 into 2H2O or 1H2O, you have to write there. That's why it also contains water. This also contains water. Gypsum, calcium sulfate, very sorry, some misconception happened. Blue vitriol, it contains water. Then washing soda, I told for you, Na2CO3 into 10H2O, decahydrate, it's also contain water. Gypsum, calcium sulfate dihydrate, 2H2O, because it also contains water. This one, all three are contain water. But baking soda, NaHCO3, NaHCO3, Okay, it's a baking soda. And sodium carbonate, it's a washing soda. Okay. Uh, uh, Whenever we are using as a baking soda, they not contains the water, but at the time of a preparation of what sodium carbonate with water is there. Okay, that's why what option B is the right answer. Next, which of the following is acidic in nature? Acidic in nature. Okay, human blood, it works. I said for your whole body works in between 7 to 7.8. Means it's a neutral. Neutral means blood is also neutral. Lime water, calcium hydroxide. Calcium hydroxide is a base. Okay, that's why it is also it's also very sorry, it is also what basic. Then antacids mixture of a sodium hydrogen carbonate with what we use a weak acids, tartaric acid or weak acid. That's why compared in these four, slightly acidic is there, but compared to in these four, what uh, lime juice, vitamin C, and citric acid is there. That's why it's acidic in nature. Compared to this tartaric acid, lime juice, okay, more acidic. Okay, we already discussed this one. Okay, now we are going to discuss about 1 mark questions. Okay, 1 or 2 mark questions these are. Name the acid present in the following. Name the acid present in the following. First one, tomato. In tomato, oxalic acid is there. Then next, vinegar, acetic acid is there. Acetic acid, CH3COOH. Okay. Then tamarind, tartaric acid is there. Ant sting. In ant sting, methanoic acid is there. Next question. Explain the action of a dilute hydrochloric acid on the following chemical reaction. Okay. What hydrochloric acid reaction they asked with A, B, C. For example, first one, magnesium ribbon. Magnesium ribbon reacts with the hydrochloric acid. Okay, magnesium ribbon reacts with the hydrochloric acid. What it gives? It gives a magnesium chloride with liberation of hydrogen gas. With liberation of what? Hydrogen gas. Here hydrogen gas is produced. Next, B. Sodium hydroxide. Sodium hydroxide reacts with the hydrochloric acid. It gives a sodium chloride and water. It's a neutralization reaction because acid reacts with a base. It gives a salt and water. Whatever the reactions give a salt and water, those are called as a neutralization reactions. Whenever the acid reacts with a base, if they give a salt and water, those reactions are called as a neutralization reactions. Next one, what C, crushed egg cells. Crushed egg cells contains a calcium carbonate. If they reacts with the hydrochloric acid, what they give? They give a calcium chloride, water, and carbon dioxide is released. Okay, that's why calcium chloride is formed. Egg cells are made up of a calcium carbonate. You are given two solutions A and B. The pH of a solution A is 6 and pH of a solution B is 8. Then identify acidic and basic. Which one is acidic and which one basic? Which solution has a more hydrogen ions concentration? Give reason for answer. They ask. Acidic solution is A. Why? Because its a pH is 6. Acidic solution A. Why? Because its pH what 6. And basic solution B. Why? Why? Because its what pH is 8. Then identify the acidic and basic solutions finished. Then solution A, because of identify now which solution has a more hydrogen ions concentration. They asked solution A has a what more hydrogen ions concentration. Why? Because hydrogen ion concentration is higher in acidic solution. In which solution? Acidic solution. Write the name and formula of each of the following. Okay, an acidic salt example ammonium chloride NH4Cl, and basic salt sodium carbonate Na2CO3, neutral salt sodium chloride NaCl. Next question, define pH scale. A scale measure what a scale for a measuring hydrogen ions concentration in a solution is called as a pH scale. It's called as a pH scale. Define universal indicator for what purpose it is used. Define universal indicator for what purpose it is used. Universal indicator is a mixture of many different indication which gives the different colors at different pH values of the entire pH scale. Okay, it is used to measure the different substances pH. Different substances pH. Mention the pH value below which tooth decay begin, how this fall below this value, explain the ill effect of the acidic medium in the mouth, how can this be prevented. The what tooth enamel made up of a calcium phosphate. Okay, calcium phosphate, it is corroded with the help of pH below 5.5 because if a mouth pH is 5 below 5.5, then it is a more acidic. In more acidic condition, what calcium phosphate corroded. Calcium phosphate corroded, that's why it's important. Then bacteria present in the mouth produce acidic by degeneration of sugar and food particles remaining in the mouth. Then it can be prevented by using toothpaste, which is generally basic. Toothpastes are generally basic. 5 solutions A, B, C, D and E when tested with universal indicator. Okay, A, this is a B, this is a C, this is a D, this is a E. Then these are the solutions. Then neutral solution. In this neutral solution, whatever the solution, its value is 7, that's a neutral solution, that's why it is a D. Then second question, what they ask, weak acid. Weak acid they asked, 4, 1, 11, 7, 9. Which is a weak acid? Weak acid, it's a what? A, B, C. A, B, C. Oh, sorry. First one, what they asked, A, neutral. Neutral they asked, it's a 7. 7 means A, B, D, finished. Then what they ask, strongly alkaline. Strongly alkaline. Strongly alkaline, what are the substances pH is high? pH is high, those are strongly alkaline. It's what? 11. Its pH is C's pH is 11, that's why it's strongly alkaline. Then C, strongly acidic. Strongly acidic, solution B, its a pH is 1, that's why it's strongly acidic. Then fourth one, weakly acidic. Weakly acidic, 4, 1, 11, 7, 9. Weakly acid, weakly acid A, its pH is 4. Its pH is 4. Then last question, weakly alkaline. Weakly alkaline, whatever the substances pH is, whatever the substances pH is, weakly alkaline. Which one is weakly alkaline? Whatever the substances pH is, what more basic. Not high basic, it's a more basic, means 7 to 10 we are called weakly alkaline. 10, 11, 12, 13, 14, these are strongly alkaline. That's why what option, weakly alkaline, it's a which one, A, B, this one A, this one B, this one C, this one D, this one E. Okay, that's why weakly alkaline. Weakly alkaline, which one is weakly alkaline? Okay, option E, its pH is 9. Which pH is 9? 7, 8, 9, these are weakly alkaline. 10, 11, 12, 13, 14, whatever are there was a strongly alkaline, because 11 comes under strongly alkaline. Okay, strongly alkaline, we already discussed here, option B, strongly alkaline. Mention the pH range. Mention the pH range with in which our body works. Explain how antacids give a relief from acidity. Write the name of one such antacid. Our body works within 7 to 7.8 range. During indigestion, stomach produces too much of acid, which causes irritation and pain. Which causes irritation and pain. Antacids are alkaline and so neutralizes excess acid. Okay, name of the antacid. Magnesium is milk of a magnesia that's prepared from magnesium hydroxide. Magnesium hydroxide is called as a milk of magnesia. Write the balanced chemical equation only for the following chemical properties of acids. When acid reacts with a metal, when acid reacts with a metal, for example, acid is a sulfuric acid, it's reacting with a metal like a what, zinc, then what it gives, it gives a zinc sulfate with the liberation of hydrogen gas. Okay, that's what they asked. Write a balanced chemical equation. See here, hydrogen 2, hydrogen 2, zinc 1, zinc 1, sulfate also 1 here. That's why it's a balanced chemical reaction. Then next, when acid react with the metal bicarbonate, metal bicarbonate, it's what, sodium hydrogen carbonate. Metal bicarbonate is a sodium hydrogen carbonate. For example, it's reacting with acid hydrochloric acid, and what it gives a products, it gives a product sodium chloride, water and carbon dioxide in the form of gas released. Okay, that's why it is also, see what, hydrogen, how many hydrogens are there? Two, here two are there. Okay, then carbonate, here three oxygen, here one, and here two, three oxygens are there. Here also sodium one, here also sodium one, chlorine one, chlorine. That's why no need to balance a chemical reaction. No need to balance a chemical reaction. This also, this also. Next one, which one? Hydrochloric acid. When acid react with a base, okay, it's a neutralization reaction. Acid, hydrochloric acid, base sodium hydroxide. What hydrochloric acid reacts with a base, it gives a sodium chloride with water. It's a neutralization reaction. That's why here also no need of a balancing chemical equation. Why? Because hydrogen, here one hydrogen, here two, how many? Two, two. Here one chlorine, here one chlorine, sodium one, sodium one. That's why no need to balance this chemical reaction. Then question number 11. Farmer treats the soil with quicklime or calcium carbonate. Farmer treats soil with quicklime or calcium carbonate. What is the nature of the soil? Why does the farmer treat the soil with quicklime? Okay, see here. Farmers want to neutralize some acid and hence add a basic substances like quicklime or calcium carbonate to it to minimize the acidity of the soil. To minimize the acidity of soil. Next, what is meant by the term hydrated salts? Give two examples for hydrated salts. Whatever the salts contains water, those are called as hydrated salts. For example, washing soda, sodium carbonate, decahydrate. I already explained for you. Then gypsum, calcium sulfate dihydrate, CaSO4 into 2H2O, Na2CO3 into 10H2O. And plaster of Paris, CaSO4 into half H2O. Okay, calcium sulfate hemihydrate, it's called as a plaster of Paris. Okay, these are all what? Hydrated salts. The salts contain a water, what crystals, those are called as a hydrated salts. The salts contain a water of crystallization, those are called as a what? Hydrated salts. How many molecules of water present in hydrated copper sulfate? Write its formula. Okay, in copper sulfate solution, 5 molecules of water are there. Okay, then its formula is CuSO4 into 5H2O. Okay, copper sulfate pentahydrate. Next, write the chemical formula of bleaching powder. Write the balance equation involved in the preparation of bleaching powder and write its three uses. Write its three uses. Chemical formula, calcium oxychloride. Chemical equation, calcium hydroxide reacts with a chlorine. It gives a calcium oxychloride and with liberation of a hydrogen gas. This is called as a what? Balanced chemical equation. Okay, balanced chemical, no need to balance because LHS is equal to RHS already done there. Okay, next, what they asked in this question, and write three uses of a bleaching powder. They asked bleaching powder, it is used to bleach, it is used to bleach in cotton and linen industry, textile industries, but as an oxidizing agent in chemical industry. Bleaching powder is used as an oxidizing agent in chemical industry. And what, to disinfecting water, to kill whatever the germs are there in water, calcium oxychloride or chlorine gas is used. That's why It is also use of a bleaching powder. What happen when a solution of a baking soda is heated? Write chemical equation for the same. Name the product which is responsible for making a bread or cake spongy and fluffy. When baking soda is heated, when a baking soda is heated, baking soda NaHCO3, it is heated in presence of what it is what in presence of high temperature means heated, then it gives a products like sodium carbonate, water and carbon dioxide is released. The released carbon dioxide makes the bread or cake puffy. Makes the bread or cake puffy. When a baking soda is heated, it decomposes to produce a sodium carbonate, water and carbon dioxide gas. Carbon dioxide gas produced during the reaction makes the cake or bread spongy. Whatever the bubbles are formed, those bubble structure remains as it is. That's why cake or bread turns into fluffy or spongy. What happen? State what happen when gypsum is heated at 373 Kelvin. When gypsum is heated at 373 Kelvin, calcium sulfate dihydrate heated at what 373 Kelvin, what it gives? It gives a calcium sulfate hemihydrate plus 1.5 water. Okay, this is the reaction. Gypsum is heated at 373 Kelvin. This is the what reaction. Then it loses what water molecules and become a calcium sulfate hemihydrate. It's a calcium sulfate hemihydrate and calcium sulfate 1.5 water. The mixture of these both, it is called as a plaster of Paris. It's called as a, this reaction is a what used to prepare a plaster of Paris. Calcium sulfate dihydrate, it's a gypsum heated in 373 Kelvin, then we get a plaster of Paris. Next one, excess carbon dioxide gas is passed through lime water. If we pass a excess carbon dioxide gas to which one? Lime water, calcium hydroxide, then what it gives? It gives a calcium carbonate with water. Okay, on passing carbon dioxide gas through lime water, what insoluble calcium carbonate is formed. Insoluble calcium carbonate is formed on passing the excess of carbon dioxide gas, and what soluble calcium bicarbonate is what calcium bicarbonate gas, no, calcium carbonate is formed here. Next, name the three products of a chloralkali process. Three products of a chloralkali process: sodium hydroxide, chlorine and hydrogen. These are the what byproducts of chloralkali method. Next, name one commercial important of material each that can be prepared from the each of these products. Chloralkali method, whatever the products are formed, okay, you write the uses of those they asked. Okay, then first, sodium hydroxide, what it is used in the preparation of soaps and detergents. Okay, and it is also used in paper making industry. Okay, it is also used in what artificial fibers making industry. Then next one, chlorine gas. Chlorine gas, it is used to prepare a PVC, polyvinyl chloride. PVC, polyvinyl chloride, and it is also used in the preparation of pesticides to kill pests. And it is also used in the preparation of CFC, chlorofluorocarbon. In previous days, we use a CFC in where? In refrigerators and air conditioners. But nowadays, what we are using? We are using HFC. Okay. So next. Hydrogen, next one, hydrogen gas is also liberated in where? Chloralkali process. So hydrogen gas is used to prepare fuels, margarine, ammonia for fertilizers. How, sir? They ask. Nitrogen reacts with the hydrogen, what it gives? Ammonia, and ammonia used in the preparation of fertilizers, because whatever the nitrogen containing fertilizers are there, those are all prepared with the help of ammonia. Differentiate between strong acid and weak acid. Okay, first of all we have to say strong acid. Acid which completely dissociate in aqueous solution, produces a large amount of hydrogen ions, it is called as a strong acid. Hydrochloric acid and nitric acid. Then weak acid, acid which ionize partially or dissociate partially in aqueous solution, produces a small amount of hydrogen ions, it is called as a weak acid. Example, acetic acid and citric acid. Acetic acid and citric acid. Acetic acid is present in vinegar, citric acid is present in lemon. Next, why does tooth decay starts when the pH of a mouth is lower than 5.5. At lower pH below 5.5, the calcium phosphate of enamel of a tooth gets corroded, which leads into tooth decay. List out the uses of sodium carbonate. List out the uses of a sodium carbonate. That's a washing soda. Washing soda Na2CO3. Then uses you have to see. It is largely used in the production of detergents and soap. It is used in the manufacture of soap. It is used in the production of rayon polymers. It is used in water softening. To make a hard water into soft water, we use a sodium carbonate. Not only sodium carbonate, to make a hard water into soft water, we use a what sodium aluminum silicate, that's called as a geolite. And ion exchange process also we use to what convert a hard water into soft water. List out the uses of sodium hydrogen carbonate. List out the uses of sodium hydrogen carbonate, that's called as a baking soda. Baking soda, NaHCO3. NaHCO3. Okay, baking soda is used in what leavening, in cooking, used as a baking soda. Next, pest control. Sodium carbonate is an effective way to control a fungal growth. Then fire extinguisher, it is used to prepare a soda acid fire extinguisher. Okay, these are the what important uses of sodium bicarbonate. List out the uses of plaster of Paris. List out the uses of plaster of Paris. Okay, plaster of Paris used for making molds and statues, used as a fire extinguisher material and making a chalks. Okay, whatever the fireproof dresses are there, those firefighters wear, those are prepared with the help of plaster of Paris. Okay, to making a molds and statues, small molds and statues, Buddha or what Ganesha statues, we use a plaster of Paris. Used in hospital for what immobilizing the affect part in case of a bone fracture or sprain. Okay, what a plaster of Paris, they make a coating on hard coating that's made of a plaster of Paris at the time of a fracture. And what in bone injury also they use a plaster of Paris as a material. Then they asked one diagram here, to mark diagram. It's a draw a diagram to show reaction of a zinc granules with dilute sulfuric acid and testing hydrogen gas. Okay, see the important parts of this experiment. Here we took a strand. Okay, test tube is there, dilute sulfuric acid is there, zinc granules are there. Okay, whenever the zinc granules reacts with the sulfuric acid, they produce what hydrogen gas bubbles. Those hydrogen gas bubbles, with the help of a cork and what a delivery tube, they passes to the another container. Another container contains a soap solution. Soap solution, the bubbles are filled with hydrogen, are very light and they start to fly. And whenever we bring a candle near to those bubbles, burning of hydrogen gas with a pop sound, they make a pop sound because they are highly inflammable. They are highly inflammable. This is the what diagram and important parts. Then draw a diagram to show acid solution in water conducts electricity. Last class, whenever we discussed chemical equation and reaction, in that chapter also we discussed this diagram, but by mistake they given this diagram to their water electrolysis. One diagram is see how it's diagram. Okay, this is a what one beaker, very sorry, this is a what one beaker. In this beaker we kept two tubes. Here what we fix electrodes. These electrodes are connected to positive and negative terminal of the battery. One side hydrogen gas is collected, and other side oxygen gas is collected with the help of electrolysis. This is the water hydrolysis of water. In first chapter is there, but that diagram they not given. This diagram they given there, by mistake they given. So see parts of this diagram. Okay, in beaker we kept a bottom what rubber cork, and we took a dilute solution of hydrochloric acid. Two nails are fixed to rubber cork. Then it's a beaker, then switch, bulb, and 6-volt battery. The dilute solution of a hydrochloric acid dissociate into water, and it forms ions. Those ions are helpful to carry current. That's why this bulb start to glow. This bulb starts to grow. Okay, acid solution in water conducting electricity. Okay, up to now what we discussed about acid, bases, and salts as a revision topic. As a what? A revision topic. In next clip, we are going to discuss about metals and non-metals. Which chapter we are going to discuss? Metals and non-metals. Hopefully, these are useful for your exam purpose, passing as a passing package, or what to score more. These are helpful videos. So if you feel these are helpful, then share and subscribe to tell to your friends to share, and tell them to subscribe also, and yourself also subscribe. Thank you so much. Why I'm saying again and again this word? Because in my channel, whatever the videos we watch, there 87% non-subscribers watch my videos, and only 12%, okay, subscribers watch videos, and from other sources 1%. So I am requesting you to subscribe and share. Thank you.